Hi everyone. Today we are doing more derivative graphs. This worksheet right here is going to help us understand the difference between a direct question about a graph versus maybe like an indirect, like not so obvious question. I'm just going to jump right in here with number one. Number one says f of x is graphed. It's very, very, very important that you understand what is being graphed because how you answer the questions varies whether you're looking at the function or the derivative. Questions tend to be easier when you're looking at the function. So the first two, we're looking at the function. Part A, that's what I would consider a direct question. It says, state the intervals over which f of x is greater than 0. It's direct because it's asking me about the function that's graphed. So if it wants to know about f of x greater than 0 means, use my highlighter here, means where's it above the x-axis? So where's this guy above the x-axis? I would say from -1 to 1. And then again after 5, so 5 to infinity. That's where it's above the x-axis. Part B, that's your indirect question. It says, state the intervals over which f prime of x is greater than 0. So where would the derivative be positive? Okay, well, I'm not looking at the derivative, so I have to know more information. Where would the derivative be positive? Well, that's going to happen when, I'm going to just try writing with something else for a second. We'll see how this goes. That is going to happen when, nope, that didn't work. F of x is increasing. So that I'm going to highlight. F of x is increasing there. F of x is increasing there. So how am I making this correlation? Based on the fact that the derivative is the slope. So if the derivative is the slope, then the slope is going to be positive in those places where I just highlighted. So -infinity to, remember we're doing x values, so I'm not going to say like 5 because that would be a y value, to 0. And then that x value looks maybe 3.5. Let me check my answer key. Yep, I'm consistent. I put 3.5. And the rest of the way. Okay, so why don't you guys pause, do number 2 since it's the same idea, and then unpause and check with mine. Okay, so if you're looking at my number 2, part A, where is the function greater than 0? That's going to be above the x-axis. It's only above the x-axis from 2 to 4. State where the intervals over which the derivative is positive. The derivative is positive when the function is increasing, and I've highlighted that. 1 to 3 and 5 to 6. Okay. Now, what's changing in 3 and 4 is that I'm given the derivative. Again, this tends to be the harder type of question for students. The fact that I'm given the derivative is really important to note. Okay, for what values of x is f increasing? Also important to note, this is not a direct question. Actually, none of them are direct for part 3. Why am I saying they're not direct questions? Because they're giving me a graph of a derivative, but they're asking me about the function. So when they're asking about something else, it's more to read into. Okay, so for what values of f is it increasing? So that's going to be when the derivative is positive. So this is backwards from what I was just saying. I have to look for where this guy is above the x-axis. Those are going to be the places where I know the regular function is increasing. So it looks negative, like -infinity to -6.6. And then it's positive again from 0 to 3.6. Does that mean it's increasing? The derivative is increasing? No. You could tell when I drew this, I went down. And then here I went up and down. So I'm not looking for where this picture is increasing. If I want to know where the function's increasing, that means the derivative has to be positive. So knowing that the derivative is positive, let me go to my laser pointer. Here we go. Okay, it's red, but knowing that the derivative is positive means that the slopes on the original are positive numbers here. Then the slope is 0, and then the slopes are negative numbers. Then the slope is 0, then the slope's positive numbers. Then the slope is 0 again, then the slope has negative numbers. Okay. So B, for what values of x is f decreasing? Well, there I'm looking for negative slopes. When the function is decreasing, I'll just draw something that's decreasing. When the function's decreasing, it has negative slopes all along here. So that's reflected in the graph of the derivative with negative numbers. The answer to part B is negative 6.6 to 0 and 3.6 to infinity. Hopefully you're listening so that you could see what I'm saying or hear what I'm saying. What can you conclude about f of negative 6.6? I'm going to erase a little bit here. I don't really know why this does that. Okay, whatever. Okay, so if I'm looking at negative 6.6, I'm looking right here. What can I conclude? Well, I can conclude that that's a place where the derivative changes from increasing to decreasing. So if that's a place where the derivative changes from increasing to decreasing, then what is it? Let me draw it. If something goes from increasing to decreasing, I definitely have a turning point there. More specifically, okay, it's probably, it could be a relative max. When I say at this point, when we're just saying max and mins, we're not distinguishing between relative max and mins. It's definitely a max because if it has to go, when you read graphs, you go left to right. So if I'm reading this graph from left to right, I'm going, okay, the derivative is positive. That means the function is increasing. Okay. Then the slope is 0. So then the slopes are negative. So it's got to be decreasing. And the slopes are negative. That's how I can translate what's happening from the derivative graph to the function graph. I'm not going to act like, you know how I say a lot, like, this is easy, this is easy. I'm not going to be saying that here. This stuff is, it's like once you get it, it makes sense, but I just know that it takes a lot of examples and a lot of like just repeating the same thing for students to really get this. So, you know, it's hard for me right now not being able to be like standing in front of you, asking you every single little minute thing, you know, as we talk about the graph, but we're doing our best. Okay, the derivative is graphed below. Again, very important that this is the derivative. State the intervals over which f prime of x is greater than 0. This is a direct question. This is asking me about the derivative, and I have the derivative graphed. So where is the derivative greater than 0? Well, nowhere. It never goes above the x-axis. So I'm just going to say none. What does this tell you about f of x? Well, if the derivative is never positive, then that tells me that f of x never increases. It never increases. It never has a positive slope. The derivative, yeah, this is something I would probably be writing on the board a lot. Every time we're talking about the derivative, I'll often just replace the word derivative with slope. The slope is never positive. The derivative is never positive. Well, the slope is never positive. Once you start like replacing the word derivative with slope, things start to make more sense. If the derivative is never positive, the slope is never positive. If the slope is never positive, then it never increases. Okay. Okay, I'm on the next page. And at the top, we have 3 pictures. The graphs of derivatives of the derivative of function f, g, that should say h, are shown above. Oh my God. Which of the functions have a relative maximum on the interval a to b? Okay, so here's the wrong way to do it. And this is what makes this stuff tricky. Is that students will look at it and they'll be like, oh, which ones have a relative max? That one has a relative max. That one has a relative max. That one has a relative max. All of them. And you'd be wrong. That's the wrong way of thinking of it. Even if the answer was all of them, that's the wrong way of thinking of it. This is not a direct question. These graphs are the graphs of the derivative. So, if we're given the graphs of the derivative and we are asked about the functions, we cannot look directly at that graph and look for a maximum. What we have to do is think, if the derivative is graphed, what is a maximum going to look like? Well, here's a maximum. We know what a maximum is. It does that, right? So think about what the slopes are there. The slopes left to right are positive. Then the slope is 0 right at that maximum, and then the slopes are negative. So how is that reflected in the graph of the derivative? If this is the function, the derivative is going to have to go from above to hitting the x-axis to below, in that order. So I'm not just looking for any x-intercept. I'm specifically looking for an x-intercept that goes left to right, above, at the x-axis, there's my 0, to below. So I can get rid of choice H. It doesn't even hit the x-axis in that interval. G prime does hit the x-axis, but not in the right way. This one goes from below to above. And when the derivative goes from below to above, that means the function goes from decreasing to increasing. That would cause a minimum. We want the function to go from above to below, like it does here. So f is the only one that has a maximum on it in the interval a to b. And how can I tell? Not by looking for maximums, but by looking for this type of x-intercept, the kind that goes from above to below. Okay, that's a really important question. And if you can wrap your brain around that concept, you're doing really well. I am going to erase because I want to talk about graph F, just because it happens to have a lot going on. So just erasing just so we're not distracted by any of that other stuff I have written down. Okay, so I'm going to zoom in a little bit on graph F. And this is the derivative, keep in mind. So if I'm talking about the function f, what does this indicate is happening on the function? Well, that's telling me that my slopes are negative, then my slope is 0, but then my slopes are still negative. So how does that happen? Well, if my slopes are negative, and then my slope is 0, and then still negative, this means that on the function, I would have a horizontal point of inflection. We wrote this down in our table last week. Whenever the derivative is tangent to the x-axis, we're going to have a horizontal point of inflection. Okay. What does this indicate about the graph of f? Well, my slopes are negative, then they're 0, then they're positive. If my slopes are negative, then 0, then positive, I have a minimum. And then that last part we already saw, but just to reiterate, if the slopes go from positive to 0 to negative, positive slopes, 0, negative, I have a maximum. Okay. All right. Let's take a look down here. Number 7. F of x is graphed at the right. Very important to note that it's f of x and not f prime of x. For each blank below, fill in with a greater than, less than, or equal to at x equals 1. Okay, so here I'm asking you for just, is the regular function greater than, less than, or equal to 0? And then separately is the derivative. So at x equals -1, okay, we're looking right there. Well, the function is read as is directly. So the function is at 0. So that guy gets an equal sign. The derivative is not what's graphed. So the derivative, we have to do more thinking. The derivative there is also 0, but not because it's at the x-axis, only because it's a turning point. If I go to draw in a tangent line there, it would have a slope of 0. Okay, you guys can like go ahead a little bit and then see if we're matching. At x equals 1, so at x equals 1, we're right here. I'm just going to mark a point on it. That kind of helps me when I'm discussing it. The function is below the x-axis, so I'm going to say the function is less than 0. At x equals 1, is the derivative positive, negative, or 0? Well, the function is increasing. If I were to draw a tangent line, it would be positive, so the derivative in that case would be greater than 0. At x equals 2, the function is at the x-axis, so it's equal to 0. It's not above or below. The derivative there is also 0, not because it's a turning point, but because it is a horizontal point of inflection. If I were to draw a tangent line in there, it would be horizontal. The next one, D, is at 3. I'm going to say it's about there. So the function is definitely greater than 0. That is above the x-axis there. The derivative is also greater than 0 because it's positive. It's increasing there, so the slope is positive. At 4, so 4 is right here. The function is equal to 0 because it's at the x-axis. The derivative is less than 0 because if I were to draw on a tangent line right there, it would have a negative slope. Okay, that's it for that one. I'm probably going to add some of those exam gen type questions. Those are similar, those are like what you'll see in AP Calc with the graphs. I would probably try the questions on that worksheet first, and I will do some of the questions from it. All right, hope everybody's doing well. Bye.